Dear students, Assalamu alaikum. Welcome to the first program on Software Engineering 1. The purpose of this course is to familiarize you with the basic concepts and principles of software engineering. In this course, you'll also learn different methods, tools, and techniques which are used to build high-quality software. Today, we are going to start with our first lecture. Today, we are going to discuss what is software. We'll explain how software is different from other engineered products. We'll also explain what we mean by a well-engineered software. And finally, we'll discuss why do we need to engineer the software. So let's start by defining the software. The software is defined as computer programs that provide desired functionality and performance. It also includes documentation associated with development, user documentation, and data. Dear students, you might have noticed one very simple thing in our definition. That is, traditionally, software is defined as only the code. But in our definition, we have included the documentation, both the technical and the user documentation, and the data as the part of the software engineering product. This definition is quite useful from the system development point of view. Dear students, it's not important how precisely we define what is software, but what's important when we treat this software as a product to see how this software product is different from other well-engineered products. So let's see how a software is different from other products. The first, software is a logical rather than a physical entity. The second difference is software is a product and at the same time a tool for developing a product. Dear student, that's very interesting observation about the software. Software is not only a product which gives its functionality. That is, a software basically provides some services and information to the user. But at the same time, software has a dual role. It can be used to develop other software. For example, we use the case tools. Also, software can be used to control different devices. So that's a very unique feature of a software product. Another interesting observation between the products and the software product is software is engineered or developed and not manufactured. Of course, manufactured in the classical sense. Software is not like manufacturing a car. Software basically is engineered or developed for which the components are not available. Another interesting observation about the software is software does not wear out, but it does deteriorate. What do we mean by it? As you know, all the products and all the physical products, the environment has the effect on it. With the temperature and other environmental effects, the products do wear out with time, but the software is a little different. If you look at the graph, you see here is the failure rate and we have the time. Ideally, when we develop the software, there are a lot of bugs in it. With time, we fix the bugs. Therefore, the failure rate decreases, and ideally, it should be parallel to the time axis. But in reality, it's not like that. This is the real situation. When we develop the product, of course, the failure rates are high because of the bugs in the software. With the time, we fix those bugs, and the failure rate starts decreasing. But a time comes when we have to make the changes into the software. Dear students, that's very important to note. Software is not a static entity. Software is a dynamic entity which does change with time. User keep giving you the new requirements. As the time goes, we have to improve the functionality of the software. The software has to adapt to the evolving technologies. All these things contribute to making the changes in the existing software. But when we make a change in the software, we introduce new bugs in it. And that's what this graph shows to you. When the changes are made, new bugs are introduced, and you can see that spike there. The failure rate again increases. Again, we start fixing those bugs, and a time comes when we reach the next maintenance point, where the new changes come, and we have to accommodate the new changes. And new changes again introduce new bugs in it. And similarly, the process goes. Another interesting thing to note in this graph is you can see the actual curve does not follow the idealized curve. The reason is that yes, with the time we do fix some of the bugs which are introduced due to the changes made in the software, but some bugs remain undetected, and they remain in the software, and the quality of the software deteriorates. Another distinguishing characteristics of software from the other product is most software are custom built rather than being assembled from existing components. Of course, this trend is changing now. Now we are trying to develop the techniques and technologies in which we can reuse the existing components to develop the software. This will not only reduce the production cost of a software, but it also improve the quality of the software. Another interesting observation about the software which distinguishes it from other product is software are built using programming languages. Other products are built using bricks and cements and steel and other similar physical things. But the basic building block of the software is built using programming languages. These languages provide the basic tool to the programmer to write the components of a software. Dear students, we have seen how a software is different from other products. So we have been treating the software as a product which can be assembled or developed and can be sold in the market. And when you are going to sell a product in the market, the important thing is the customer. You have to satisfy the customer by providing them with high quality software. So we have to see what makes a software a high quality software. A simple definition of high quality software is if the software system does what the user wants. Of course, this is a very simplistic view of the software. Quality doesn't only mean that the software should do what the user wants now. As we have discussed before, software is not a static entity. It keeps changing with time. It has the dynamic feature in it. User requirements are not static. What the user wants today, his requirement could change tomorrow. So this software has to accommodate those changes in it. So if we say a good quality software is a software which does what the user wants now, is not enough. We have to be little more precise in it. So let's see a better definition of a good quality software. A good quality software is a software system that does what the user wants and can be made to continue to do what the user wants. It doesn't break up. Now we have seen in a previous graph that when we make the changes in the software, it increases the failure rate of the software. How easy it is to make those changes into the software, which could address the changing requirement of the user. If we can accommodate those changes into the software without deteriorating it too much, then we can make the software continue to work as the user wants it to do. But that's one view of it. There are many people who have identified precisely what characteristics a good quality software should have. We are going to touch upon those some basic attributes of a good quality software. Of course, the foremost is the correctness of the software. That's what we are working for. We have to write a software which is correct, which does what the user wants it to do. It must satisfy all the user requirements. If you write a software which does not satisfy the user requirements, it's useless for him. Another important characteristic of a good quality software is dependability. That means a user should depend on the software. He should have the trust on the software. The purpose for which this software has been written, the software is going to do exactly the same thing. That dependability feature is very important in time-critical systems and in safety-critical systems, where the software are used to monitor the patients. They are used to control the plants. If you do not have the trust on the software, of course, you will not be using that software. Another feature of a good quality software is reliability. Reliability is defined as the probability of a software to continue to work without creating any trouble. A software which has a higher probability is that software we are looking for. Reliability is the attribute of the software which is basically used by the software engineers. We run this software for an extended period of time, and we do the stress analysis of it, and we see how this software is going to behave. Or it's going to fail, or it's going to continue work correctly. A related feature to reliability is availability of the software. Availability of the software is a different way of looking at the reliability of the software. As I said, reliability attribute is basically seen by the software developers. But from the user point of view, what's more important is the availability of the software. That when the user wants to use this software is up and working. Of course, these two attributes, reliability and availability, are related to each other. If we have a software which has higher reliability, it will be available more. But that does not the case always. Suppose we have a software which has a reliability of 0.9. That means if we run that software for 10 hours, it's going to work correctly for 9 hours. But let's say that 1 hour when this software was down, that was the peak time when the user really wanted it. And this software was not available at that time. So from the user point of view, it's the availability that has the importance. Another characteristic is maintainability of the software. We have seen that software is not a static entity. We have to make the changes in the software as the user requirements change. If a software has been written in a way keeping in mind the future requirements, then of course it will be easy to make the changes in the software. So maintainability basically refers to the fact that how well a software has been written so that it can accommodate new emerging changes in it. Another very important characteristic of a good quality software is integrity. Now, integrity is becoming very important in today's interconnected work, where the hackers are sitting around and they are trying to hack your system. So integrity is the feature of the software which determines how good your software is to withstand the outside attacks. We have seen people hacking into very famous products, and then those products are sending millions of emails around the world. That is the basic flaw in the integrity of that software. Another important characteristic of a good quality software is the efficiency of the software. Dear students, we know that software has to run on some platform, on some hardware. It needs some resources. It needs the CPU, it needs hard disk, it needs RAM and other computing resources. A good software engineer will always try to use the available resources efficiently, economically. You might not have seen too many software packages. When you run them and they give you the error message, sorry, I cannot run on this software, you have to upgrade your system. Would you like to buy a software like that? Or you are working on a software and suddenly it crashes because of not enough memory there. A good quality software should also use whatever resources are available up to their optimum. Another feature of software is the usability. Now we know computer is no more confined in the big labs. It's not only used by the experts. Now you can find a computer on the desktop of everybody. They are not all computer literate in the real sense. They are only the users. They are the occasional user. They are using computer just to do their day-to-day work. They might be using word processors or spreadsheets or very simple database packages. And we have to make sure that those people who are not well aware of the computing technology can and should use our software. That should be the ultimate goal of writing a good quality software. It should be easy to use. Another important characteristic is portability of the software. That means when we write a software for one machine and tomorrow we decide to go to another machine, we want to upgrade our hardware or operating system, we should not be writing our software from the scratch. Our software should be portable. We should be capable of porting that software from one machine or from one workstation into another workstation, from one kind of hardware to another kind of hardware with minimum effort and with minimum cost. Another very important characteristic is reusability of the software. Now, reusability is no talk of the time. People have been working on the technologies such as the object orientation with a basic emphasis on the reusability. That once we put so much effort in building a component of a software, we should reuse it in other product if we have to. We don't have to invent the wheel every time we need it. Dear students, we just very briefly discussed some of the attributes of a good quality software. Now the question arises, as a software engineers, as the software developers, how much successfully we have been in developing high quality software? When we look at the history of developing this software, yes, we see some wonderful software written by us. but at the same time, there are many, many failures. With these failures, the media has highlighted them too much. And we come with a new word, what we call the software crisis. What the software crisis really means? It means that we have been struggling to develop software of high quality and reliability. Does it mean that we were bad programmers? We also see software projects were late. Were we bad estimator? We couldn't estimate the time and the cost for a project. Software is expensive. It's far more expensive than the hardware. Now you can go and buy a computer hardware by spending few thousand rupees, but if you want to buy a good quality software, you have to spend much more on it. And you don't need just one software. You need different types of software. And each and every software costs a lot of money. Question is, how can we reduce that cost of developing this software? The next important thing is, software costs more to maintain than it does to develop. That's very true. Software is not a static entity, to say again. When we make the changes in the software, of course, it needs the resources, it needs people working on it, it needs time, and that means money. Because the software we have been writing are not of very good quality generally. So they need much more effort to maintain and keep them running. And generally it is believed that if you can spend $1 in the development of a software, it will cost you more than $1,000 to keep it working. So the real challenge for the software engineer is development of high quality software within budget and time. That's what we should be looking for. Our job as a software developer, as a software engineer, is to develop a high quality software. But remember, we have limited resources. We have limited time to do our job. The question is, how can we develop a high quality software within budget and within whatever resources has been allocated to us? Let's go through an example to see that what is required to build a high quality software. We are going to take an example from the civil engineering perspective, but we'll correlate it with the software engineering. That will highlight why do we need to engineer the software in the classical sense. Let's say you want to build a dog house. Of course, a dog house can be built by one person. It requires minimum planning, very simple tools, and simple construction process. Now, if you correlate building a dog house with writing a small piece of software, a small program, you'll find that's what really we are doing now. As a student, you might have written some small programs. Of course, those programs are written by one person because the programs you wrote are not very complex in nature, they are small in size. Generally, do not plan too much for them. We use very simple tools. Might be a compiler is enough. Of course, we use a very simple procedure to write a small program. But if we take this example a little further and we discuss how we build a house. Of course, a house can be built most effectively by a team. It's not the work of one person. We need the people with different backgrounds. We need the architects, we need carpenters, we need electricians, and the people from other trades. Building a house requires model of the house. It needs a well-defined construction process. And some specialized tools. Now, building a house is like writing a software of medium size. No, it's not the work of just one person. We have to make a small team. In our team, there might be people from different backgrounds depending on the nature of the software. Now, this software cannot be built just by the creativity of a single person. We need a very elaborate process which should be used to develop that software. We need a complete design of the software. And we need some tools which can help to develop that software of the required quality within time and budget resources. Now, if we take that example a little further, on building a high-rise. Now, it requires a large team, might be more than one teams. Planning time generally exceeds the actual construction time. And it requires multiple models to be built, well-defined architecture and construction process to be used, and integration of many subsystems and some highly specialized tools. Dear students, writing a complex software is like building a high-rise. There are people working on very complex type of software. They are huge in size. That type of software cannot be built by a small team even. There are many multinational software development companies you might heard of. They have different teams working around the world, and each team is working on part of that product. Each team might be using some very specialized tools. When all those components are built, they are brought together and integrated into a single working software. When you spread the work around the world, you have to plan it well. Otherwise, the project will fail. Dear students, today we discussed what is software. We discussed how a software as a product is different from other engineered products. We also explained what makes a high quality software, what are the attributes of a good quality software. And we also showed you with the help of an example that if we want to develop a high quality software within time and budget, then we have to apply and follow the engineering principles. With this, we come to the end of our program. See you next time. Allah Hafiz.